I've got 2:01, so we will go ahead and get started. So I think many of you did participate in Investigation Phase Essentials Part 1 last week. But for anyone who is joining this call and did not participate in the first webinar last week, we covered the first half of the investigation phase, which most of what we actually talked about, you might group into the planning phase of a project or some of the planning activities. We did get a little bit into some aspects of the investigation phase itself, but in today's webinar, we're going to be going into a lot more detail and getting somewhat hands-on to the extent that we can remotely with different types of functional testing for different building equipment and systems. That'll be a big part of the agenda, and then discussing some of the documentation related aspects of essentially what's going to come out of the investigation phase. Similar to last week, I think of this as really a deep dive webinar, somewhat more technical than the first two events in the series, really intended for folks who will be delivering or executing EBCx projects, or if you are a energy manager, facility manager, working for a building owner and interested in accompanying someone delivering the EBCx or doing some building walkthroughs. This may be useful for you as well. I do just want to note before we get started, there are a lot of resources from the Save on Energy program for folks who are interested in EBCx projects. See the capability building website. If you look in the commercial sector page, then there's a group of resources about EBCx projects there for you to use, including like a 6-page practical guide that we put together last year and a set of cell sheets describing, I think of the cell sheets really as how to identify what might or might not be a good candidate building for an EBCx project for 6 different types of buildings. Also, don't want to forget to mention, Save on Energy offers an incentive program to offset some of the costs of EBCx projects. So that program uses a 3-phase approach, much like we're talking about today, with the investigation phase, moving into implementation, and then a handover and persistence phase. There are some program requirements for those who are interested. Your building needs to have an access of a minimum of 12 months of consecutive energy data. Your building needs to consume at a minimum 750,000 kilowatt hours per year. And in order to participate, your building will need to create some simple baseline models to be able to measure energy change over time. We'll have a question and answer at the end. If folks have questions about the EBCx incentive program, that can be a great time for getting those answered. I also know that some folks, as they come into the program, looking at the requirements, see it looks like quite a bit of documentation that's required to participate. And actually, one of the things that we're going to be talking about today, a lot of that documentation is things that will come out naturally from the planning and investigation phase activities. The activity log, the findings there will feed directly from any best practice EBCx project, and then could be used to meet the requirements for the program. Skip past this one. I think we've already covered it, and then I'll quickly introduce our speakers today from BPA. They'll be familiar to everyone who attended last week. But our speakers are Aurélie, Megan, and Eddie from BPA, and their team has delivered, I think, several hundred EBCx projects across Canada, and will be sharing their knowledge and expertise with us this afternoon. With that, I'll go ahead and hand it over to the BPA team.
Great, thanks, Jess. So as we were discussing in the last part 1 of the implementation or investigation phase, The investigation phase allows the EBCx team to analyze the system operations in detail. And they'll carry out the diagnostic tests, propose the measures required to optimize the operations, and then they record this in a findings log, which forms part of the investigation report. In part one of the webinar, we reviewed planning and pre-screening and planning and initial assessment. In this part of the webinar, we're going to go into more detail about the investigation phase, or the investigation itself, as well as preparing the report. So the objective of the investigation phase is to understand and document the existing conditions and performance of the building, and then identify what improvements can be made to bring that facility into compliance with the CFR, the current facility requirements, which we reviewed in part one. There's 4 different types of investigation or measures that have to be reviewed. So there's the analysis of the existing data, spot measurement, short-term performance monitoring, and longer-term performance functional testing, which is usually seasonal. During the previous part one, we discussed the analysis of existing data, spot measurement, and short-term performance monitoring. And in this discussion, or in this presentation, we're going to review the longer-term performance or functional testing. So the objective of functional testing is to validate that all the components function well and that they're in good condition. And then they can recommend repair and any replacement of those components. Also validate the actual sequence of operation and compare it to the original intended sequence of operation, and identify any opportunities to improve operation or energy efficiency. So functional performance testing, so FPT procedures for the systems identified in the project scope will form part of the functional testing. And we look at the system's performance under different operating conditions, usually shutdown, startup, normal operations, and operation during off hours. Doesn't typically include alarms, failures, or standby modes. And we look at functional testing can be done either passively or actively. Passively would be to set up trend logs and review the building automation system on site. And active would be to force the BAS by set point manual overrides or even physical changes to perform in certain ways. The active is preferred, as we can see the system operating in when we want it to, in ways we want, but it may not be possible. So if your building is occupied and the systems can't be stopped, or if it has strict indoor conditions that can't deviate, it won't be possible. An example of that would be like a hospital or a laboratory where you have to maintain strict indoor conditions. So ideally, functional testing covers every mode of operation. You're going to want to do winter functional testing on your heating systems, which would include boilers, furnaces, geothermal systems, air source heat pumps, and any circulating pumps related to that. You'd want to do summer functional tests for your cooling systems. And then on the ventilation systems, ideally you have 3 seasons. So winter, summer, and shoulder seasons. And that allows you to review the ventilation systems in heating mode, cooling mode, as well as those shoulder seasons where you might be looking at things like free cooling. For terminal devices such as VAV boxes or fan coil units, you can do that in a single season. So here's an example of a functional testing form. This one's for an air handling unit, in particular air handling 15. And it is to review the operation of the dampers and control valves. So on this form, we indicate the description of the test, how long the test is going to take, what kind of effect it's going to have on the occupants. In this case, we're predicting that it would just have, or anticipating, minor variations in temperature and airflow that might occur. We also describe how the test is performed and what the expected results are. This form is filled out before the testing is completed, and then after the testing, on-site observations and recommendations would be added. So this is just another example of a functional testing form. In this case, it's a checklist to review an operation of the BAS system.
Thanks, Megan. So I will follow up with the functional testing examples. We will look at functional testing example for typical systems, starting with ventilation systems. Here you see a air handling unit. So on that type of system, the functional test would validate that all valves and dampers, for example, actually open and close without restriction and perform as expected per the sequence of operation. So what you need to verify or test here could be fans and VFD, coils, heating coils and cooling coils, dampers, valve sensors, and maybe filters. Here we give a verification checklist, including what we can call as pre-functional verifications. So, for example, verify if filters are clean, if coils are clean, maybe verify sensor location. Is it satisfactory location? Is it in accordance with control diagrams or maybe a building automation system graphics? So with the example of coils, testing may also include measurement on the differential pressure drop across heating and cooling coils, just to evaluate if coils are clean or dirty. So here we talked about pre-functional test, and then example for a functional testing on a air handling unit. You like often the functional testing will be initiated through the building automation system. So in this example, functional test objective is to simulate a shutdown for the air handling unit. And you will modify schedule or do a manual override to do that test. The sequence of operation are reviewed here at the right, and then a commissioning provider will document what are the results expected. In that case, fans will be stopped when there is a shutdown. All dampers return to normal position. So, for example, outdoor air damper will be closed, return air damper will be open, and cooling and heating are disabled. Here, during the functional test, the commissioning provider will document any observations and maybe preliminary recommendation. We give example here, what could be observed during that test. Maybe you will see that the outdoor air damper is stuck fully open, and then your recommendation, of course, will be that repairs are required. Then another example for a air handling unit. In that test, the objective is to simulate a high cooling demand and see effects on the air handling unit. So maybe you can override several room temperatures, example set to 25 degrees Celsius on manual override, and see the effects. Still, you will compare and analyze sequence of operation and the actual operation. Here, the expected results are that the supply air temperature set point will be reset, cooling coil will be enabled, and the supply air temperature reach the set point. then the supply air static pressure set point is reset, and VFD will modulate to reach that set point. Again, the commissioning provider will document observation, and here are examples of what could be observed during that test. Maybe the supply air temperature set point was set to 19 degrees, and we see that it's on manual override. So recommendation here could be re-establish the automatic set point and maybe perform further tests to see the air handling unit operate in a total automatic mode. Another type of system that should be tested is heat recovery systems. That kind of systems should always be tested because they have a huge impact on energy efficiency. So in that case, you will want to verify and test the thermal wheel, bypass dampers, maybe sensors before and after the thermal wheel, fans and coils. Here we again we give an example for a functional testing. So in that test, the objective is to simulate a heating demand by modifying supply air temperature set points. You have here the original sequences of operation, and the commissioning provider will document what the result he expects. So thermal wheel is used at the first stage heating. The preheating coil is disabled, and thermal wheel speed modulates from a minimum to a maximum. Bypass dampers are closed when there is a heating demand and will modulate if there is a need for cooling. Observations and recommendation could be, for example, you see that there is no control sequences set up for bypass dampers, so dampers will always be closed. Here, the impact could be problematic because bypass dampers should modulate the heat recovery by modifying the airflow through the thermal wheel. If not, and with no control sequences, maybe it will create overheating, and worse, it will require cooling during mid-season and winter. So here was an example for heat recovery. Then local controls. So during the existing building commissioning project, you want to test local controls. Actually, you can test it with a sampling method. So it could be very exhaustive and very long to test all room controls, but maybe you can select several and see what you discover. So here for local controls, you will verify and test variable air volume boxes, terminal reheat if applicable, perimeter heating. Here we see a electrical baseboard, for example, maybe the airflow sensor and room temperature sensor. Here, an example of a verification checklist. For example, you could test one particular VAV box and see if it open, close, and modulate as expected. You also can check if sensor location is okay and other things like that.
Sorry to interrupt you. We got a question from Graham about the checklists, because you've shown a couple of them and they look really helpful. The question was, are they publicly available or are they proprietary? I think I know the answer, which is I think they come from real projects that you guys have done. Is that right?
Yeah, exactly. Yeah, it's from our projects, and it's really an extract from this checklist, but for some, like for example, for a handling unit, it will be very longer than what I presented here.
Right.
But Aurélie, if I'm right, I think part of these checklists are available from some standards such as CSA. don't remember the number, but there is a standard from CSA that is available if you buy it, of course. It's not a very high fee, so you could get I would say some type of checklist like that could be useful to start your own templates.
Great. Thanks for that, Eddie. Yeah, I'll track down the CSA standard number for that and share that for
I think
folks who
it's
are interested.
5,000 something, but frankly, I don't remember.
Yeah.
Okay, so yeah, for local controls, here was an example for some pre-functional verifications. And then if you want to have a proper functional testing, maybe one test could be to simulate a heating demand during, for example, unoccupied hours. So the expected result could be, in that case, VAV modulates to maintain room temperature, in that case, 20 degrees, and the electric baseboard will modulate to maintain room temperature set point minus 2 degrees, so 18 degrees in that case. For this example, maybe the VAV would be prioritized because it's from heating is from geothermal systems, for example. So it's because of energy efficiency that we can have the VAV prioritized here. Then what could be observations or recommendation? Example, you see that for the room 203, there is simultaneous heating and cooling during unoccupied hours, and you see that in that room maybe there are two VAV boxes. One is observed in cooling mode and the other in heating. So the recommendation could be review sequences of operation and maybe merge the set point for the two VAV boxes to avoid that type of problems. Here, a quick checklist for lighting controls. So what you need to verify and test for lighting could be occupancy sensors, example timeout, sensitivity and location, and daylight sensors, calibration and location. As room local controls, it could be a sampling method here used because it's a lot if you want to do every single sensor in your building. And then you will check on sweeps and schedules for lighting controls zones, if a supplemental zone maybe could be required, and lighting levels.
Okay, Lee, I'm going to interrupt again with a question that we got, because you just mentioned for lighting and lighting controls that you could use a sampling method rather than testing every lighting control in the building. We got a question about, because you mentioned using a sampling method for VAV boxes earlier, we got a question from Tony. How would you extrapolate the results from using sampled VAV data to a whole building?
Well, I will say that if you see that there is a recurrent problem happening in your sampling rooms, maybe you can say that it should be general, like in the all buildings. So maybe you could give advice to the owner and say that, okay, we will gonna do whole the building because we see that there is a major problem for local controls, or maybe there is a repetitive error in programming, for example. So it will be easier to recommend something because it's just a copy and paste maybe in the control program.
Great. So not necessarily like a mathematical extrapolation of the data, but rather if you're seeing recurrent issues, if you test 5 of them, then you may need to go back and test some more, or it may indicate bigger issues.
Yep.
Perfect. Thank you. Oh, we got a follow-on question, I think, about how to decide or prioritize which systems you want to test.
Is it concerning sampling method or in general?
Maybe I'm gonna speak to ask my
Yeah,
question.
please.
So how do you you have maybe 100 VAV boxes in the building. You want to do a, well, first, my first question would be, what would be an adequate sample first? Depending on, there's 2,000 boxes or 200 boxes or just 10 boxes. So that's the first question. And after that, once you determine how many you want to test, how do you determine which one you want to test?
Okay. Well, I would say depend on the budget, but maybe you can start with the 15% sampling and see if you can see all I don't know, different type of rooms, and in the sampling list, maybe you want to see indoor area and maybe a more perimeter area. You want to see small rooms and conference rooms. So you want to see every kind of possibility you have, type of occupancy and thermal load. So here is the
But I agree with you, Aurelie. The first thing that will, I will say, influence what is the sampling is usually the budget the client has for the investigation. So in your example, Jean-François, if you have 2,000 VAV boxes in the building, usually the client probably doesn't have the budget to cover functional tests on every 2,000 for every VAV boxes. So usually you will accept a sampling that seems to be representative of the whole building and accept that probably the what will be uncovered during the investigation apply generally everywhere.
Yeah, I mean, I kind of knew the answer, but I wanted to hear what you had as a feedback, because obviously, if you have 2,000 boxes, it might not be representative. It might be representative to maybe do 5% sampling instead of 10% compared to if you have 200. So depending on the amount that you have, statistically, you might change the sampling rate based on, like you said, the budget first, but what you consider to be a sampling that is sufficient to have a general understanding of what's going on.
Absolutely. And we've got some clients in the past that ask us to test everything. So 100% sampling, it's a bit extreme from my point of view, but it might happen also.
Okay, so we'll continue here if there is no more question. So here we want to talk about functional testing for central cooling plants. So for that plant, you will need to verify and test general condition of chillers, cooling towers, and pumps, primary and secondary. But you also want to look at the operation. So how do they operate together? Primary child loop water loop operation and secondary child water loop operation. And then heat rejection, so cooling tower, maybe dry cooler, or if there is a heat recovery chiller, so you want to see it operate in that heat recovery mode. Here is a control diagram example. So for functional testing, you will want to see the condensing water pump, a chiller, child water pump, and here the differential pressure sensor at the end of the secondary loop. Again, a verification checklist. So we see here maybe balancing valve position, lead lag control, and the point I put it in red is graphics consistent with equipment and components installed, yes or no. This point is pretty critical in not only for central cooling plant, but for the whole HVAC systems. Here, sometimes systems are misunderstood by operation staff and not operated well because of that point, because the building automation system graphics or diagrams do not correspond to reality. So here is an example to illustrate that point. You see here a diagram based on design documents. So in that case, you see there are 3 chillers installed in parallel, and all the air handling units will receive the same water supply temperature here. So air handling unit 1 until 5. And when you go on site and start your investigation, you will see that the order of connection is quite different, and it will have a huge impact on operation. So here is a diagram based on as-piped field conditions, so what you see on site directly, and it will have the impact that air handling unit 4 and 5 in that example will receive warmer water if there is bypass flow from the return here in red. So you see that it will be critical for operation, and maybe this could lead to thermal complaints for the areas deserved by air handling unit 4 and 5, and maybe a very low child water set point would be set by operation staff all year round to compensate that problem. So here you have an example of functional testing for central cooling plants. In that test, you want to simulate child water loop operation during summer season and to verify that that operation. Your comparison is still sequence of operation, maybe original or modified sequence of operation, and you will commissioning provider will document what results are expected here before the tests. So you expect that bypass valves are closed here, and a speed pump will modulate to maintain the most open valve at 95%. What could be observed on site, for example, on cooling demand with a very hot door air, all valves are open at 50% or less. So this will lead to a high pump speed, unnecessary high pump speed. Your recommendation here could be to optimize differential pressure and review minimum and maximum pressure set point to reduce that pump speed. Then the final example for functional testing is central heating plants. So again, you will need to verify all major systems here, boilers, heating pumps, and heat exchangers if applicable. You want to look at the operation of primary hot water loop and secondary hot water loop. A checklist example here, do not forget to see if there is a seasonal lockout, for example, on boilers, so you don't want a boiler to operate during summer. And then a functional testing example. So here the objective is to verify lead lag sequence for boilers and pumps during winter season. You have the sequence of operation, and you expect that the lead boiler will start automatically under a certain outdoor air temperature, and the lag boiler will also start automatically if a lead boiler in that example is above 80%. And lead lag boilers will stop automatically under several conditions. So during the test, maybe you will observe that boiler 1 and boiler 2 are at 20% load for more than 2 hours, which was not what was expected here. So recommendation could be review sequences for lag boiler, and maybe you will detect that alternation schedule for lead boiler selection is disabled, example on manual override. So this concludes functional testing examples here, and Eddie will continue the presentation here.
Thank you, Arlie. I'll just take the control from you. Just a minute.
Yeah, kind of. Yeah.
Do you see my screen? I guess so. Yes. Next we'll talk about first the findings log. The findings log is probably the most important deliverable of an existing building commissioning project at the investigations phase. This is where you'll find all the information on the recommissioning measures identified during the investigation, such as the technical description of the problem identified, the proposed technical modification, the energy savings that will be generated, the implementation cost, payback period, and what would be the suggested implementation method. NRCan has a free template that can serve as an inspiration for generating your own finding log. You can find it at the web address below the figure on the right. And the next two slides will show you an overview of this document. So the first part of the finding logs will generally consist of describing the problem detected during the investigation. So basically, these columns, what is the system affected, what is the issue that was detected during the investigation, and so on. So this part can be described in different ways, but will always include the ID of the system and equipment affected, and essentially a technical description of the problem that was found. Sometimes we can also add how the finding was made. Was it a functional test that enabled us to discover the problem? Was it by analyzing trend logs? Was it by discussing with the operator, etc.? Sorry, I have a little bit of a technical problem. Then this is the second part of the same finding log. And in fact, these two tables form a single table that is presented to the building manager or owner. The finding logs has been split for presentation purpose only. So once the problem has been described, we obviously have to propose a technical solution, a modification to the system or control to optimize energy consumption. This is where we describe the proposed measure. There are different approaches to description. For complex measure, we can give, I would say, a succinct description and present the technical detail in an appendix, which will be used during the implementation phase. And for simpler measures, all the detail can be presented in a few lines. Finally, of course, for each proposed measure, and you can see that on the column on the right, we will generally present the proposed, the implementation cost, the energy savings, the payback period, etc. We'll come back to this point later in the presentation. There is another way of presenting finding logs. It's essentially the same information, but formatted differently. An interesting addition here is the separate presentation of potential reduction in the building electricity demand as a result of this measure. I don't know if we discussed that in the earlier webinar, but generally speaking, it's less common for recommissioning measure to generate substantial reduction in electrical demand. But for some measure, this may be the case and should be included in the analysis and the findings log. In addition to the detailed description presented in the findings log, generally, we will often present a summary table, which essentially serves to summarize the project for the building manager. It's very classic and very much inspired by the summary table you'll find in any good energy audit, for example. In this case, we're only going to present a very brief description and the saving and cost figures. For those of you who attended the first webinar, I think it was last October 2023, EBCx in a nutshell, we talked about the orders of magnitude saving that are typically discovered during a recommissioning project. As a reminder, statistics show that energy saving of 10 to 20% are relatively common for a simple return on investment of an average of 1.5 years. Obviously, each building is different. Very well maintained building with an energy conscious operator will present much less potential, for example, but as an average, let's say 15% energy saving is quite common. The simple payback will also vary depending on the size and complexity of the building and systems. Which brings us to the subject of how to perform energy saving calculation. This is a topic in itself, and it could be the subject of a complete training session or even several training sessions, I might say. So the objective here is not so much to teach you how to do the detailed calculation, the formula and all that stuff, but rather to make you aware of the broad outlines of these calculations and their importance. So similar to any energy audit, the first good practice when doing energy saving calculation is to establish a good energy baseline. So what is a good energy baseline? It's the exercise of distributing energy consumption by consumption item, such as heating, cooling, ventilation, lighting, domestic hot water, and so on. The best is even to go as far as to make this energy distribution by system. So every ventilation system could be could have his own calculation. Taking into account the operating condition and sequences of operation discovered during the investigation phase. The more precise is the baseline energy, the more precise will be your energy saving calculation. But obviously the goal here is not to have a perfect precision. This is mainly to ensure that you do not propose or calculate more energy saving that the system actually consumes. So as I said in the last slide, we want to achieve a reasonable level of precision that make us comfortable, but it's not necessary to have a precision of 2-digit behind the decimal point, of course. In a recommissioning, the main activity remains to find improvement measure and make the appropriate corrective measures. Depending on the case, efforts must be adapted for the precision of the energy calculation according to client requirement, the requirement of the subsidy programs, and the potential of the measure that is proposed. We can agree that for a measure that generates little savings but is practically with no cost to implement, it is not worth spending a lot of time being precise. Rule of thumb will be sufficient in this case. Conversely, if the investments are large, and it may be worth making the estimate more precise. The calculation should also make into account interactive effect in certain cases. For example, when we reduce the lighting schedule, or could have a lot of other example on a system at the perimeter of a building in heating mode. Well, there will be this reduction in energy consumption for lighting will generate an additional heating load, which will place greater demands on the heating system. So this is an example where interactive effect must be taken into account. There are different methods for estimating energy savings in existing building commissioning. Here are some of them. First one that I would mention is the bin method. Then we can also have basic engineering calculation, rough estimate, or what I would call rules of thumb. And last, we might mention simulation software such as EQuest, Energy Plus, and so on, which are more rarely used in existing building commissioning, but still in some case they can be useful. First one, the bin method is often used in existing building commissioning for systems that affect the heating and air conditioning of the building. And in that case, the energy saving will strongly depend on the outside temperature in their energy consumption, of course. So basically, the bin method consists of having an Excel spreadsheet which summarize how many hours per year are found in different outdoor temperature range. The graph presented here is a good example of this, where we see, for example, a distribution of temperature and hours of occurrence for 3 different years for the city of Ottawa. Therefore, if a recommissioning measure make it possible to reduce the heating or cooling load, or even the humidification load, for example, this data will make it possible to make energy saving calculation based on external or outdoor conditions. An example of such a measure would be to introduce a temperature setback in winter in a building that did not have one previously. The measure will reduce the heating load, which is obviously a function of the temperature differential between the indoor temperature and the outdoor conditions. The bin method will be particularly useful for this type of calculation. We'll see an example of that in the next slides. So here we have an example where we have a makeup air system. So it's a 100% fresh air system with heat recovery by an enthalpy wheel and an heating coil, in that case, electric source heating. So normally during recommissioning, you will be able to collect the characteristic of the system, such as airflow rate, set point temperature, heat recovery efficiency, etc. So you have an example of that in the left column of this slide. So if you want to do the energy saving for that system, it's a good example where the bin method might be useful. So let's say, for example, that you discovered during recommissioning that this system was operating for no good reason 24 hours a day, when in the end, the occupants are only present 12 hours a day from Monday to Friday. The saving calculation with the bin method will therefore consist of calculating the reduction in heating demand on the heating coil for each outdoor temperature range and multiplying by the number of operating hours before and after the recommissioning to establish the energy savings. We see here an example of that calculation in the Excel spreadsheet. So in the left column, we have the outside temperature, which would be the middle of the temperature range. Then we also have beside in the next two columns the number of operating hours for each temperature range before and after the scheduled change. Then the commissioning provider would do some engineering calculation to determine the outlet temperature after the heat recovery. So that would be the enthalpy wheel that we saw on the last graph. and the heating demand to reach the supply set point temperature for each temperature range. For the rest, it's a simple calculation of energy consumption by multiplying the heating demand in kilowatt by the number of operating hours for each range of operation, and comparing energy consumption before and after the recommissioning measure. So that's a good example of a bin method for energy saving when a system is particularly affected by heating and cooling and outdoor air condition. Here's a more basic example of a recommissioning measure where we could use a simpler engineering calculation. So in this case, it was a measure where we found that the occupancy sensor in conference room were deactivated. We therefore want to reactivate them and use them properly. So in this case, these are very simple calculations where we will simply multiply the active lighting power by the number of hours when we anticipate that the room will be unoccupied to determine energy saving. I would say that we cheated a little bit on this example because there's no interactive effect that are presented, but basically we do the assumption in that case that conference room were all in internal area of the building, so we don't have heating interactive effect in that case. But of course, if you do the same measure with room that would be on the perimeter of the building, you would have to consider interactive effect in that case.
Eddie, you would have interactive effect on your cooling system, so technically you would get a little bit more savings. You could
you're right. You're right. But I wanted to make a simple example for engineering calculation. But I agree with you. In that case, there would be interactive effect for the cooling. You're right. But as I said, I think we could do 4 hours or even a few hours just to show the energy calculation. So the goal here is basically to show some example, and I think that most of you already have I would say the knowledge to do that kind of calculation. The last method I'll talk about is the simulation software. I mentioned a couple of them. So we have basically most of you will know Energy Plus, eQuest, IES, VE. So there's a few of them on the market. I would say they are not commonly used in recommissioning project because basically first they ask for a lot of effort to do the energy model, so it's not a really quick process, and also they are ill adapted to do the kind of calculation we need in recommissioning, because basically these software are assuming that the system are working perfectly. And this is exactly the case of the type of measure that we want to estimate in recommissioning are for situation where the sequence of operation or the way that the system are operated is imperfect. So they are not really easy to modify to do the type of calculation we need for recommissioning. So they are not commonly used for these type of measure. There are some exceptions to that rule, I would say. An example that comes to mind is do a more complex calculation for temperature setback for a whole building, for example. They can be useful to do that type of measure, but I would say it's quite uncommon to use simulation software to do energy saving calculation in recommissioning. So usually when we present the final report of investigation, the energy saving calculation will be presented as a whole and also measure by measure. and we will be able to present to the client a comparison of energy consumption before the EBCx project and after the EBCx project. And that will be useful for him first to take his decision on what measure you want to implement, and also to do afterward after the measure are implemented, to do energy follow-up and see if this target is reached when the project is completed. I will give back the presentation to Megan that will present you what is exactly in the investigation report.
Before we do that, I just want to bring up a question that we got kind of midway through what you were presenting there, Eddie. I think it's a great question to kind of bring us back to the nuts and bolts a little bit. But Graham asked, what's usually the role of the building automation system provider in an EBCx project that you're describing here, and in the particularly in the investigation phase? Do you often find the BAS provider getting involved in some of these investigations, or is it typically the case that the EBCx provider and the building owner will do the investigation and then just hand over those findings and results for the BAS provider to implement?
The answer to that is it varies. It varies according to what type of BAS system you have in that specific building. So some BAS system are, I would say, more black box type, so more difficult to obtain data and to see what is the programmation and the sequence of operation in the BAS system. So these are, in that case, it's more common to have participation of the BAS contractor in the investigation process. Also, you have the example where your building operator is well versed in his BAS system, so you don't need much involvement from the BAS contractor. So that's another example where we will not necessarily be in contact with the BAS contractor at the investigation phase. So it really depends on every building type, BAS system. Also, what are the capabilities of the EBCx provider? At BPA, for example, we have people that come from BAS contractor. They have worked there before, so they know quite well how to access the BAS programming of some type. So it's easier to do that on your own rather than again have the BAS contractor involved during the investigation. So it depends on a lot of factors. I don't know if I answer your question, but depends on a lot of factors.
That was great, and we can come back to it at the end if there's more. Thanks for that.
Perfect. Megan, did you take back control on the presentation?
Yeah, Aurélie has control of it. Yeah.
Okay, thank you.
Okay, so the investigation report. So that is the next phase, and it's considered phase 2 on the Save on Energy slide. We were to scroll way back to the beginning. And it's done after the investigation report. I'm skipping ahead. We're talking about the investigation report at this point. So the investigation report is an essential part of the investigation phase, and it provides all of the documentation that was recorded and put together through this phase. So it usually contains all of that information, the observations, measurements, and any tests that were conducted during the investigation. It will include the building site and facilities description, building documentation review, the current facility requirements, the CFR that we talked about in the first webinar, utility bills analysis, findings logs, and the summary of the investigation, which will include detailed findings, summary of any on-site observations, diagnostic and monitoring results, that's usually in an appendix, and the functional test results, usually in an appendix. The next few slides, we'll just go through quickly, but they're samples of what you would find in a investigation report. So you'd have the table of contents showing you all of it. And you can see that this one includes, a list of the appendices that we referred to, as well as including things like photos and site reviews. Here's an example of the description of the site building. Includes of the site, includes building layout, description of the mechanical systems. Here's the utility history, the analysis of the bills, the condition assessment that we referred to before, and a general description of the results of interviews with the stakeholders. It also would include functional testing results. So description of what was observed and the results of that, more in paragraph form as opposed to the appendice, which would have the actual forms. In your appendices, you might want to include the notes that were made when interviewing. This is the questionnaire for the building maintenance. So this was included as an appendice in one of our reports with the notes, everything that was discussed. Another example of appendices would be the functional systems test forms as they were filled out, anything that was observed and fully completed. And then the final appendices in our examples is the checklists and the review of the BAS. So this is a review of the whole sequence of operations and the controls for the BAS. Okay, this is what I was jumping ahead to. Finishing the, this is the end of the investigation phase. So the very final steps would be to review the findings with the owner, and the EBCx provider would review these with the owner, and the owner would then select measures for implementation, often with the assistance of the EBCx provider. And then the commissioning plan is updated and for implementation and handoff. So the next phase, phase 2 with Save on Energy, is the implementation phase. The implementation activities usually include completing additional investigation and engineering that might be required, developing the implementation plan, hiring any subcontractors as required, implementing the selected findings, verifying the implementation of verifying the success of the implementation measures, adjusting any estimates of energy savings and costs, updating the EBCx documentation, and preparing a implementation phase summary report, and planning for ongoing commissioning. So the owner can choose 3 different ways to implement or to prepare for implementation. They can look at a turnkey project. They can prepare it using the help of the EBCx provider, or they can do an owner-led implementation. And the decisions of which type to do is usually determined by what's available for internal resources and of the skills of the internal resources, as well as the type of measures to be implemented. So the turnkey implementation, why would the owner choose this approach? Well, if the operations staff is not available to do the implementation, or they don't have the necessary skills to implement these measures, an example of this might be adding a VFT on a pump with the new hardware and the installation required for that VFT. May not be able to be, most likely wouldn't be able to be done in-house. So in a turnkey implementation, the EBCx provider manages and oversees all of the implementation activities, and the owner only has one contract with that EBC provider. The EBCx provider hires and deals with all of the subcontractors as required, and the EBCx provider implements and implements the selected measures and verifies the results. The second option would be the owner can implement this with the help of an EBCx provider as a consultant. So the owner would choose this approach if the in-house staff can implement most of the measures and the owner has time and the expertise to manage this implementation. An example of this would be something where there's some simple programming required for the BAS, or sensor calibration, or maybe some schedule optimizations. For this option, the EBCx provider offers support and oversight of the implementation activities, and the in-house staff or any subcontractors hired by the owner would implement the selected measures. And it's the owner who manages these contracts with the subcontractor. The EBCx would provider verifies and documents the results of the EBCx implementation. The owner-led implementation, this is where the owner manages and oversees the entire process. So this would be done in a case where the owner has implemented energy efficiency measures before on a building in his portfolio and has the highly skilled internal resources required to do this. The owner would call his service contractor, who he has an established relationship with, or has an in-house engineer who can implement and verify the measures. And this approach requires a significant commitment from the owner. So the implementation plan itself. On the right is an example of an implementation plan template provided by Enercan. It includes a detailed description of the measures, so the scope of work, the implementation method, how it's being done, the expected results, and the verification method. It also includes the order of the implementation and any O&M requirements. The implementation report, here's the example of completed implementation report, and it's completed by adding the implementation status, the status of the implementation measure, a summary, the results of the verification, and any recommendations for the future. And that would tie up that implementation phase. So we can open up the floor to any questions or discussion.
Excellent. Thank you, Megan, and Aurélie and Eddie as well. Thanks for everybody who has submitted questions along the way. I think we have been able to respond to all of the questions that folks shared so far. So at this point, if you do have other questions or ideas you want to talk through with the team or with other participants, please feel free, open your mic, open your camera, and join the discussion. I'll get things started while people are still warming up their brains from the listening phase to the discussing phase. I wonder, I think I asked a similar question during one of the earlier webinars in our series, but based on your experience, what do you find are some of the more common pitfalls or mistakes, things that maybe get overlooked the first time during an investigation phase of a project that then, you know, once you get into implementation or measurement and verification, you realize, oh shoot, wish we'd have done that and need to come back and take care of it later on?
Well, the first thing that comes to my mind, at least, is you need to involve the building operator when you are proposing a specific measure on a system. Because most of the time you will probably have more information to explain to you why he did he changed the sequence of operation, the programming, or whatever else. And this information is most often crucial in knowing how to correct or to prevent the problem from occurring. So the information, the opinion of the building operator is most important, and he must be involved in, I would say, buying the measure and wanting to implement that in his building, because he's the one that is going to operate the system afterwards. So that's my answer to that.
Great. And Denis jumped in with the hard questions, asking about expected costs for EBCx. And I think this is going to be another one of those, it depends, but can you put any kinds of parameters, or it depends on types of factors to bound that?
Well, you're right. It depends on a lot of factors. It depends on the type of measures, depends on the availability of documentation on the building, depends on the involvement of the building operator. I mean, for example, in some buildings, the building operator is able to implement most of the measure, even do the correction to the programming of the system. So it will bring down a lot the cost of implementation. So it depends on a lot of factors. I think in the first webinar, EBX in a nutshell, we presented some statistic on what is the cost of EBCx for different type of building and so on. I would refer to that first webinar. I could find the information because it's a statistical presentation that we did on the first webinar. But basically, I would say that most of the time, simple payback period are quite fast, below 3-4 years for the different EBCx measure. So it's usually still a very good project for every building owner.
Great, and I might turn that question out to, I mean, we've got about 50 folks here, particularly those of you who maybe work with a portfolio of buildings, own or manage a portfolio of buildings, and have done some EBCx projects in the last, I don't know, 3, 4, 5 years. Does any of you want to chime in on the cost question as it pertains to your own experience? Well, feel free to do so in the chat. I think I know Denis is interested, but I bet others are as well. I see Kathy, you have your hand up. Do you want to go ahead and open your mic and ask away?
Yeah, thank you, Jess. My question is really regarding the template. I know that you guys shared some examples in your slides. I was wondering if there's Excel template or Word template that's available that would standardize the procedure. So, you know, the technical staff and the consulting, the CPs, we can just focus on finding the opportunities on site, and then just preferably filling the blank if we can, to report back the result to expedite the process.
Mm-hmm. Well, I don't want to do any publicity for RNCAN training session about recommissioning, but I remember vividly that in these presentation and the documentation that they have online, and I think it's free, they have a few templates to present finding logs, investigation report, and so on. So I would refer you to that as a first example. As I said earlier, and we could find the information, but I know that there's some commissioning standards that will propose, I would say, checklists and different template to do the functional testing of different type of system. So these are relatively easy to find depending on the CSCA standard. And that's about it for my part. I don't know if Aurélie, you have any other idea, or maybe people from the IESO.
Yeah, I think we shared like the most common resources that we found helpful for existing building commissioning project. So yes, ENARCAN, and you also have the Building Commissioning Association, who has a good guide and you know, some, yeah, I think it will be helpful for templates. A report template, I don't think it exists, but you know, like findings log, we present a template from Natural Resource Canada, and yeah. Staff interview, I think you will also find a template from Natural Resource Canada.
Yep, and for the reporting document that you just mentioned, thanks, Jody, for chiming in the chat. The EBCx program from Save on Energy does have a template for commissioning providers to use, and there's an email address there. You can contact the program to obtain that. And then, as Eddie said earlier in the first half of the discussion, when it came to the checklist, the CSA Z5001-20 standard has a lot of those checklists when it comes to the functional testing, and the link for that is also shared above in the chat.
Okay, thank you very much.
And I was a little bit remiss in responding to the cost question and didn't mention, so cost is you know, variable and a challenging question to answer in general, but I should just say the EBCx program from Save on Energy does provide that incentive is 6 cents per square foot up to $50,000 for the investigation phase activities. And then there's additional incentives at 3 cents a kilowatt hour for energy savings achieved from the implementation activities. So there is incentive support there to offset some of those costs. Graham also sent another question. What are some of the pitfalls you've seen when it comes to owner-led recommissioning? Have you had to work on a site where an owner-led recommissioning project has failed or not produced good results, and then you were called in?
Failed? I will not say failed. The challenge that I see when it's owner-led is usually it's a long process because there's less pressure to complete it. I mean, the people that will try to do the commissioning have a lot of other tasks, and recommissioning will maybe not be their first priority in that case. Rather than when you give the contract to an external contractor, well, you can put pressure on him to complete the recommissioning in I don't know, 5 months, 6 months, a year, or so on. So I would say it's the main pitfall that I've seen in the past. Another example, we had a case where we were the recommissioning provider to do the investigation, and the client was supposed to, well, he was able to do the implementation of the measure by himself. But again, it's the same pitfall. The building operator that was able to do the programming of the system had a bunch of building to supervise and other problems to take care of, and it took a long time before the new programming and operating parameter were put in place. So that would be the pitfall that I see in those cases.
Great, thank you. Any other questions? Lee, would you mind just advancing the slides by one? Perfect. I just want to note for folks, if you are thinking about recommissioning project and interested in a little bit of expert advice or support to help you get started with that or get through a certain step in the process, that type of support is available from Save on Energy. Please reach out to us at the email address trainingandsupport@ieso.ca with requests like that. And then I shared the link earlier, but the other information and training support is available at these websites here. And with that, I'll just say a big thanks to the BPA team and to everybody else who participated, especially those of you who hung in with us last week and today as well. Really appreciate you sharing your time. Hope everybody has a great rest of your day.
Thank you, everyone.
Thank you.
Thank
Thanks.
you.
Oh, we did get a last question here. Folks who want to feel free and drop off, but I saw a question come in at the end. Maybe we can talk about real quick. Denny asks about implications for a building that has never had has never been commissioned to start with.
Probably more potential. So that's the first implication. Second, it's very common. I mean, most of building that were built between, I don't know, most building built before I would say 2010 didn't have a proper commissioning, and I would say that there's still a lot of building that don't have a proper commissioning process, even built this year and last year. So it's not really it will not really hinder the process of doing an EBCx project. Might be more difficult to have information about the programming, the sequence, and all that stuff, but you can find this information in the BAS contractor documentation. So it doesn't prevent you to do an EBCx project. It will be a bit different, and there might definitely be more potential because it was never properly commissioned first. So
yeah, that makes a lot of sense. Maybe a little bit more effort required, especially in those early planning and development stages, but probably, if anything, more potential, more value for that building that's never been commissioned properly in the first place.
exactly.
Great, thanks, Denny. Thanks, everyone. I'm going to go ahead and close the event.
Thank you.
Have a great day.